Hello, this is Dr. Amita Telam. I'm going to discuss the topic evolutions of operating systems. First of all, we will see the basic concept of operating system. An operating system acts as an intermediary between the user of a computer and computer hardware. It is basically a system software, and the purpose of this operating system is to provide an environment in which a user can execute programs conveniently and efficiently. An operating system is software that manages computer hardware. The hardware must provide appropriate mechanism to ensure the correct operation of the computer system and to prevent user program from interfering with the proper operation of the system. A more common definition is that the operating system is the one program running at all time on the computer, with all else being application programs. An OS is concerned with the allocation of resources and services such as memory, processors, devices, and information. The operating system correspondingly include programs to manage these resources such as traffic controller, scheduler, memory management module, input-output program, and a file system. Some of the important responsibilities that operating system hold are device management. The operating system keeps track of all the devices. So it is also called input-output controller that decides which process gets the device, when and how much. Second, file management. It allocates and deallocates the resources and also decides who gets the resource. One more job one more job performed by operating system is error detecting, memory management, processor management. In memory management, it will keep track of primary memory. In processor management, it allocates the processor to a process, then deallocate the processor when it is no longer needed. It also acts as a control on system performance. It records the delays between the request for a service and the system. Security. It also provides security. It prevents unauthorized access to programs and data using passwords or some kind of protection technique. An OS allows the computer system resource to be used efficiently. Throughput. An operating system should be constructed so that it can give maximum throughput. Some of the major functions of operating system are resource management, process management, storage management, memory management, security or privacy management. These all kind of responsibilities and functionalities not only keep operating system the most important in the most important step in the computer system. By resource management, operating system control all the access of the systems, all the resource, hardware, software resource, and it also decrease the load in the system by resource management. By process management, operating system schedule and terminate the process. By storage management, operating system keep track of hard disk. By memory management, operating system keep track of how much memory has been used. By security and privacy management, operating system uses password so that unauthorized applications cannot access program or data. Today, operating systems are an integral part of computing and are used in various devices, including desktop, laptops, smartphones, tablets, and other. Evolution of operating system. Since 1950s, the evolution of operating system is divided into six main types, and the evolution of the past 70 years can be seen in this picture. Serial processing. The history of operating system begins in 1950s. Prior to 1950s, programmers directly interacted with the hardware as there was no operating system available at that time. If a programmer wished to execute a program in those days, the following sequential steps were necessary. Type the program or punch card, convert the punch card to a card reader, submit to the computing machine. Is there any error? Check for the errors. The error was indicated by the lights. The programmers examined the register and main memory to identify the cause of an error. Take output on the printer, then the programmer ready for the next program. So in this era, this type of processing is difficult for users. It takes much time and the next program should wait for the completion of the previous one. The programs are submitted to the machine one after another. Therefore, the method is said to be serial processing, after which it comes batch processing. So before 1960s, it is difficult to execute a program using a computer because of the computer located in three different rooms. One room for the card reader, one room for executing the program, and another room for printing the result. The user or machine operator runs between three rooms to complete a job, and we can solve this problem by using batch processing. In batch processing technique, same type of job can be run together and execute at a time. The carrier carries the group of jobs at a time from one room to another. Therefore, the programmer need not run between these three rooms several times. After which it comes multi-programming. Multi-programming is a technique used to execute multiple programs simultaneously on a single processor. In multi-programming, several processes resides in the main memory at the same time. The operating system selects and begin to execute one of the programs in the main memory. Now suppose that in the main memory, 5 jobs at a time are present and the CPU executes them one by one. In a non-multi-programming system, the CPU can only execute one program at a time. If the running program is waiting for any IO, the CPU becomes idle, which negatively affects the CPU performance. In a multi-programming environment, if a process is waiting for IO, the CPU switches from that process to another process in the job pool. As a result, the CPU is not idle at any time. So, multi-programming is advantageous from all aspects. Some of the advantages served by multi-programming operating systems are increased CPU utilization, faster processing of input-output operations, efficient use of system resources, improved system throughput, improved user productivity, and reduced wait time. Let us move to time sharing system. Time sharing, or it is also called multitasking, is a logical extension of multi-programming in which multiple tasks are executed by the CPU by switching between them. The CPU scheduler selects a task from the ready queue and switches the CPU to that task. When the time slice assigned to a task expires, the CPU switches from that task to another task. So, in this method, the CPU time is shared among different processes, making it a time sharing system. Generally, the time slices are defined by the operating system. Some of the advantages of time sharing system are it is efficient utilization of CPU resources. It was developed to provide interactive use of a computer system in a reasonable cost. Time sharing operating system uses CPU scheduling and multi-programming to provide each user with a small portion of a time-shared computer. Another advantage of time-sharing OS over a batch processing system is that the user can interact with the job while it is executing, which is not possible in batch system. Let us move to parallel system. There is a trend multiprocessor system. Such systems have more than one processor in close communication, sharing the computer bus, clock, and sometimes memory and peripheral devices. These systems are referred to as tightly coupled systems. Then the system is called a parallel system. In the parallel system, a number of processors are executing their job in parallel. Some of the advantages are increased performance by dividing a task among multiple processors or cores. Parallel operating systems can complete tasks faster than traditional single core systems. Second important advantage is improved reliability. If one processor or core fails, the other processors or core can still continue working. This increases the overall reliability of the system. One more advantage is scalability. Parallel operating systems can scale to support more users and higher workload by adding more processor or cores to the system. Better resource utilization. Parallel operating system can utilize the system resources more efficiently than traditional operating systems because tasks can be distributed among multiple processor or core. Increased flexibility. Parallel operating systems can customized to meet a specific need and can be configured for different types of workload. Now let us see distributed system. So in a distributed operating system, processor cannot share a memory or a clock. Each processor has its own local memory. The processor communicates with one another through various communication lines such as high-speed buses. These buses are referred to as loosely coupled system. Some of the advantages are if multiple sites are connected by high-speed communication line, it is possible to share resources from one site to another. For example, let us consider two sites S1 and S2 which are connected by communication lines. Suppose S1 has a printer but S2 does not. Then a distributed OS, it is possible to access printer from S2 without physically moving to S1. Therefore, resource sharing is possible in a distributed operating system. A large computer is partitioned into number of subsystems which are run concurrently. One more advantage is if a resource or system fails in one site due to technical problem, we can use other systems or resources in some other site. Therefore, the reliability of the distributed system increases. So,
These are the 6 main types of operating systems that have been evaluated over the past 70 years. That's it for this topic. Thank you so much.